All right, so this is just a bunch of area review in case you need more help with finding area. If you don't, then you can just try these practice problems on your own and check the answer key. All right, so number 1 says find the area of the regular octagon with a perimeter of 400 centimeters round the nearest hundredth. So we're going to start off with our formula for a regular octagon, which is 1/2 apothem times perimeter. So I have area equals 1/2, and then I'm going to reread this. Was I given the apothem? No. I'll leave a space for it. Was I given the perimeter? Yes, 400. All right, so now I need to find the apothem, so I'm going to draw a center in the middle of this octagon. I'm going to drop a perpendicular line to one of the sides. That creates a right angle, and it's also going to give me 2 congruent segments because it's actually a perpendicular bisector. I don't know the apothem, so I'll call that A. I'm going to draw on a radius, and then I do know this little piece. So if the perimeter is 400, I can do 400 divided by 8 to find the measure of each side. So that is 50. And then divide that by 2 to find this little piece right here. So 50 divided by 2 is 25 centimeters. Yeah, 25 centimeters. All right. So now I can find the apothem, but I need that little angle there. So to find that little angle, we have 360 divided by 8, which is 45 degrees. And then I'm going to divide that by 2, which is 22.5 degrees. And if you already know, like you've done 10 octagon problems, or even you just have a really good memory and you know it's 22.5, then just put that it's 22.5. All right, it's not a special right triangle, so I do have to use SOHCAHTOA to get the apothem. I have opposite and adjacent. So we have tangent of 22.5 is equal to opposite, which is 25, over adjacent, which is A. And then we are going to cross multiply to solve for A. So we have, I'll put this over 1, A times tangent of 22.5 is equal to 25. And then to get A apothem by itself, divide by tangent of 22.5. That cancels, and I have the apothem, which is what I'm looking for, is 25 divided by tangent of 22.5. All right, so now I need my calculator. I'm going to pull that up. Okay, I'm going to move it over so it's not ginormous. All right, so I'm going to do 25. Ooh, that's a Z5. That's not a 25. 25. Actually, I'm going to put that in parentheses. I don't like the way I feel about that. So 25 divided by tangent of 22.5. Close the parentheses, and then times 400. And then take this and divide it by 2. And I get, wowza, that's a lot. 12,000, it's big side, 71.07 centimeters squared. All right, I'm going to try that one more time in my calculator just to make sure I did it right. 25 divided by tangent of 22.5. See what that is. And then times 200. Okay, I feel okay about it. Let me just check my mode. Oh, I'm good on my mode too. Okay, there's my answer. All right, here's the next one. Find the area of the regular hexagon, round to the nearest hundredth again. Okay, area equals 1/2 apothem times perimeter. All right, 1/2. Was I given the apothem? So people are quick to say that this is the apothem. But remember, the apothem goes from the center to the center of one of the sides. So I was not given the apothem. That's my apothem. I was given the radius instead. So I don't have my apothem. And I don't have my perimeter. I don't have either, but that doesn't mean I can't do this. It just means I have a little bit of work to do. All right, so I don't like the fact that that little triangle up there is upside down, so I'm going to draw a brand new one because I just feel the need to. Right here, I'm going to say I don't have my apothem. These two pieces are congruent. I do have my radius. It's 8 meters. Okay, so I need to find that little teeny tiny angle right there. All right, so I'm going to do 360 divided by the number of sides. This is a hexagon, so that's 6. That's 60 degrees. And then I'm going to divide that by 2, and that's 30 degrees. So I know this angle is 30 degrees. Okay, so I need to find my apothem. I also need to find my perimeter. I can start by finding my apothem. Now, I do notice that this is a 30, 60, 90 triangle. So I'm hoping that I don't have to use SOHCAHTOA. I can. I don't want you to think you can't. But if you know your 30, 60, 90 triangles, you don't have to use it. Okay? So what I'm going to do is I'm going to say across from my 90 is my double side. That's 8. So that means across from my 30 is my short side, which is 4. And across from my 60-degree angle is my 4√3 side. Now, if you get that wrong, you're not going to get any points for it. So you have to make sure that you know those 30, 60, 90s. Or if you don't feel confident, use SOHCAHTOA to find your apothem. Use SOHCAHTOA to find this little piece right here. Okay? So I know my apothem now is 4√3. And I can get my perimeter pretty easily. I know that this little piece is 4. So that means my side, oops, there's an E inside, is 2 times that. So 2 times 4 is 8. And that means my perimeter is 8 times 6, because there's 6 sides, which is 48. Look, my perimeter is a nice answer. How lovely. Okay. Now, if I use SOHCAHTOA, then I'd probably have a really, not probably, I would have like a ugly answer for, let's see what I would get. So 30, that's opposite over hypotenuse. 8 sine of 30, and then times 2 is 16 times 16 sine of 30, and then 16 times 6 is 96. You have 96 sine of 30. So you'd be saying that the perimeter is 96 sine of 30, but if I type 96 sine of 30 in the calculator, I get a 48. Okay. Same thing with your apothem. You'd have that's adjacent over hypotenuse, so cosine, so 8 cosine of 30. So if you have 8 cosine of 30 for that and 96 cosine of 30, we'll get the same answer. It's just mine was faster. All right, so I'm going to do 4√3 times 48, and then divide this by 2, and I get 166. Area equals 166.28 meters squared. So notice knowing your 30, 60, 90 triangles is a time saver. Okay, next one, find the area of the trapezoid. So I need to know my area of a trapezoid formula. Area equals 1/2 base 1 plus base 2 times height. All right, so area equals 1/2. I need my 2 bases added up. So my bases are my parallel pieces. So that is the 14 and I don't know this. Okay, so 14, I'll leave a space for that. And then my height is perpendicular to my bases. I see right angles right here. So this is my height, which is 8. All right, I need to find that second base right there. So what I'm going to do is I'm going to break it into a rectangle. And this one's one triangle, right? So here's my rectangle on the left there. This is 14. This is 14. This is 8. And then I don't know what this piece is, so I'll call it X. And if you look, zoom in, I can find it using Pythagorean theorem. It's also a triple, so if you know it, you can just say what it is. X squared plus 8 squared equals 10 squared. X squared plus 64 is equal to 100. Subtract 64 from both sides. X squared, whoa. X squared is equal to 36, and then square root, positive answer only, 6 meters. So X is 6 meters, and now your base, this base right here, is 14 plus 6, which is 20 meters. 20 right there, and now we can go ahead and put that in our calculator. So 34 times 8, that's 14 plus 20 is 34, times 8, and then divided by 2. 136 meters squared. All right, let's check out the next one. Here we have a parallelogram. Area is equal to base times height. Remember, bases and heights are perpendicular. I didn't read the directions. There's no way it's this easy, okay? Draw and label a triangle that have the same area as the parallelogram. Well, I do need to find the area. Bases and heights are always perpendicular, so I'm going to highlight my base and my height. Here we go. So I see my height is 6. And at first glance, I look like I don't have my bases, but remember, opposite sides of a parallelogram are congruent. So my base is 10, and I get the area is 60 centimeters squared. So I want to draw a triangle that has the same area. So I'll start off by drawing a triangle. Okay, now I want to make sure that I'm putting in perpendicular pieces. I'm going to put a dashed line because I feel it. So I need to be able to label the base and the height. Now you could just draw a right triangle and then avoid having and put the right angle in there, and then then you can avoid drawing what I had to draw, right? And then we want to label our base and our height. Now remember, for a triangle, we want the area to be 60, and the formula is 1/2 base times height. So we need 3 numbers, 1/2 times base times height, that multiply to give us 60, right? If you want to solve for base and height, like if you just want to get base times height on that side, you could get rid of this times 1/2 by multiplying both sides by 2. So really what we're doing is we're looking for 2 numbers that multiply to give us 120. So I'm going to do 12 and 10. 12 and 10. So I'm going to make one of mine base, either my base or my height 12, my base or my height 10. So I can say this is 12 centimeters and 10 centimeters. Or I can go 12 centimeters and 10 centimeters. And it doesn't matter which one's which, but make sure you put your units on it. Now if you check it, 10 times 12 is 120, and then remember you have to divide it by 2, 60. Works. Find the exact area and circumference of the circle. Area of a circle is pi r squared. Notice I'm practicing by writing out my formulas each time. Pi times 5 squared. Area is 25 pi centimeters squared. Circumference is 2 pi times the radius. Circumference is 2 times pi times 5. So the circumference is 10 pi centimeters. Okay. Next one, find the exact area of a circle given the circumference is 22 pi centimeters. So I was given the circumference and I need to find the area, right? So I'm going to write down both my formulas. Area is pi r squared. Circumference is 2 pi r. Now remember, I want to find area. So I'm saying area is equal to pi times, I need the radius squared, which I wasn't given the radius directly. Instead, I was given circumference. So what I'm going to do is I'm going to take this 22 pi and plug it in here. So 22 pi is equal to 2 times pi times radius. So I want to solve this equation for radius so I can plug a radius into my second equation. So to get radius by itself, I'm going to divide by 2, and I'm also going to divide by pi. Divide by 2, and I'm also going to divide by pi. 2 divided by 2 is 1. Pi divided by pi is 1. So I have r equals on this side. Pi divided by pi is 1, and then 22 divided by 2 is 11. So the radius is 11 centimeters. I can put 11 in here. And then my exact area, 11 squared, is 121. So I have 121 pi centimeters squared. See that? All right, we have another pentagon here, and then we have a composite figure wall, a shaded region. Find the area of the regular pentagon with a side length of 16. Round your answer to the nearest hundredth. Area equals 1/2 apothem times perimeter. Area equals 1/2. Was I given the apothem? No. Was I given the perimeter? Not directly. But I can find the perimeter pretty easily. The side length is 16. And there are 5 sides to a pentagon, so that is 80 inches. All right, now I need to find the apothem. So I'm going to zoom in here, draw my center, label the apothem A, right angle, 2 congruent pieces, make my radius. All right, what did they give me? They gave me a side length of 16. So this little piece right here is 8 inches. That little angle in there, 360 divided by 5 sides, which is 72 degrees. And then divide it by 2 to get that angle, which is 36 degrees. SOHCAHTOA to get your apothem. So here's my angle. This is opposite. This is adjacent. Tangent of 36 degrees is equal to opposite, which is 8, over adjacent, which is A. Put tangent over 1, cross multiply to solve for A. A times tangent of 36 is equal to 8, and then divide both sides by tangent of 36 degrees. That is your apothem, remember, and that's what we're looking for to put in our formula. 8 divided by tangent of 36 degrees. I don't like how I left a little teeny tiny bit of room, but it's okay. All right, so a parentheses, 8 divided by tan 36, close the parentheses, times 80, enter, divide this by 2, and I get area is equal to 440.44 inches squared. Okay. Last one, find the area of the shaded region. So first off, I'm going to start off by making a plan. Round to the nearest thousandth, right? Plan. So what I see here is a giant rectangle with 3 circles in it. And I just want the shaded region. So what I'm going to do is I say, okay, the big part is the rectangle, right? I'm going to find that area. And then I'm going to subtract those 3 circles. Okay? So I'm going to find the area of the rectangle. I'm going to find the area of one of the circles. They're all the same. And then I am going to subtract 3 of the circles off of the rectangle. So let's start with area of the rectangle. I'll use an R for rectangle. And I know that formula is base times height. And at first glance, it looks like, oh no, I don't have either of those. But I have both. Okay? All right, so the height is this right here. And if you look, you're given the radius of the circle. So I know that the diameter is 14. So if this is 14, so is this. And then the diameter is 14. So that's 14, that's 14, that's 14. So if I do 14 times 3, 14 times 3, ooh, goodness, that's not good. 14 times 3, I get 42. So I know that the base, oopsies, is 42 inches. See that? So base 42, height 14. 42 times 14 is 588 inches squared. All right, now I need to see area of the circle. I only need to find one. Area of the circle. Ooh, circle. Pi times the radius, which is 7 squared. So area of one circle is 49 pi inches squared. Now I just got to follow through with my plan. So my plan is to take 588 and subtract 3 circles. Okay, now it says round to the nearest hundredth, so I'm typing the whole thing in my calculator. So I'll get my area is 588 minus 3 times 49 pi. And I get 126.19 inches squared. Voila. All right, you should have a re-rating, but it's not there for some reason. So go, oh, there was never a rating because this is review. All right, but think about how you feel, and then you can go ahead and get started on your homework.